Today, on how it's made. Carburetors. Air conditioners. And sugar. Cars that don't have fuel injection systems have carburetors. They're an integral part of the engine that mixes air and fuel in specific proportions, vaporizes them, then sends the mixture to the intake manifold. The manifold transfers the mixture to the engine's cylinders, where combustion occurs. Filtered air enters the carburetor and mixes with fuel. When you press the gas, the carburetor opens conduits for the air and fuel mixture to flow to the engine. Two metering blocks control the proportion of fuel to air. Computer-guided precision tools machine them out of aluminum. Meanwhile, workers install components called boosters in the carburetor's main body. These boosters spray the fuel and air mixture as a mist into tapered conduits called venturi. Those lead to the intake manifold, which transfers the mixture to the engine's cylinders. Another computerized machine makes each throttle shaft from a bar of steel. These shafts turn when you press on the gas, pivoting the butterfly discs that open those conduits to the intake manifold. The tooling machine bores screw holes for attaching the butterflies and carves grooves to prevent fuel from leaking out. Workers install the throttle shafts in the carburetor's base plate. One side of this plate will bolt to the main body, the other to the intake manifold. The butterflies are made of aluminum, steel, or brass, depending on the carburetor model. He flips the base plate and flares the bottom of the screws to prevent them from vibrating out and falling into the engine. After installing an adjustment screw for tuning the carburetor and using thread locking fluid to ensure the components don't loosen, it's time to assemble the levers that turn the throttle shafts. A washer and a cotter pin hold it all together. A few pulls on the levers ensures that both throttle shafts move freely and smoothly, turning the butterflies perpendicular to open the conduits and flat to close them. Next, the accelerator pump arm. It shoots an initial burst of fuel when you start the car. The carburetor's cast metal fuel bowls go into a vibrating tumbler where metal balls smooth their surface. Then they receive a protective coating. Now a worker installs a float to control the fuel level inside each bowl. This is essential because too little fuel would prevent engine startup and too much fuel would overflow and cause a shutdown. A gasket sandwiched between the main body and the base plate will prevent fuel from leaking out and dirt from seeping in. As a precaution, they coat the base plate screws with thread locking fluid so they won't loosen over time. Now the base plate that contains the throttle shafts and butterflies is connected to the main body that contains the boosters. Next come the metering blocks, a gasket over each one, and then into a fuel bowl. Then one block and bowl unit goes on each side of the main body. Just one final adjustment to the accelerator pump lever and arm, and the carburetor is finished. In the quality control department, Every carburetor undergoes testing with fluids similar to gasoline. They check if the accelerator pump squirts out enough fuel at ignition and during the transition from idling mode to acceleration. Then, once everything's running at regular speed, they measure the amount of fluid the boosters spray per hour. Once they've passed quality control, these carburetors will really be able to rev you up. In an air conditioner, liquid refrigerant absorbs heat from inside the building, changes into a gas, and flows outdoors. It goes through a compressor, then a heat exchanger coil that transfers the heat to the outside air, turning the refrigerant gas to liquid again. The refrigerant then circulates back inside the building. This air conditioner company makes its coils entirely of aluminum, which is 5 times more corrosion resistant than coils made of copper and aluminum. To make the coil, workers position an aluminum tube, called the spine, in the middle of the special winding machine. Then they feed in an aluminum strip. The machine slits the aluminum strip into thin teeth, called fins. Then it folds and wraps thousands upon thousands of fins around the spine, making a material they call spine fin tubing. Each tiny fin is a heat transfer vehicle. Now, to form the coil, they hook the end of the spine fin tubing to an automated winder. It spirals the spine fin tubing into a large cylindrical shape. When they finish winding the coil, they cut the end free from the feeder, then apply hot glue to hold everything together. The next machine presses the coil on all sides to form it into the shape of the air conditioner. A worker now cuts into the coil and bares a row of tubing. These cuts determine the circuits, the term for the path the refrigerant takes as it flows through the coil. The pipes that feed these circuits are made of copper, but copper doesn't fuse directly to aluminum, so workers must first solder on transition tubes coated with a zinc-aluminum alloy. Then they attach the copper manifolds that distribute the refrigerant to the circuits. Once all the refrigeration components are in place, workers subject the coil unit to an underwater pressure test to make sure there are no leaks. In another department, workers have assembled the air conditioner's compressor. They mount the compressor to a weather-resistant plastic base, then cover it with a sound reducer, a vinyl jacket filled with fiberglass insulation. Now they add the coil. It sits between posts in the base. For an air conditioner to work well, it can't have air or moisture in its refrigeration system. So workers hook up the unit to automated machinery that completely evacuates the lines. Next, workers connect wiring and install corner supports, then begin assembling the unit's exterior housing. The top perimeter piece is shaped to direct the airflow out of the unit. A motorized fan pulls air into the unit. A plastic grill lets air exit and keeps debris from falling inside. Finally, they seal the refrigerant lines by brazing shut a pair of tubes. The housing parts are made of zinc-coated steel. The factory spray paints them, then bakes the paint for maximum durability. Air conditioners sit outdoors, so they have to withstand all kinds of weather. The factory sends sample units to a performance testing laboratory. It runs them in extreme heat, extreme cold, rain, and snow to see if, under such harsh conditions, they keep their cool. Next time you reach for the sugar bowl, try to imagine that it was once so rare and expensive, it was called white gold. Producing sugar from the sugarcane first took place in India. About 300 BC, Alexander the Great's army reported seeing a reed that gives honey without bees growing there. This table sugar has many names: mill white, plantation white, and crystal sugar, but it all comes from the sugarcane. It looks a lot like bamboo, with fully grown stalks that can measure up to 6 meters high. Here in the field, a worker pares away the husk from a stalk of sugarcane, then chews the cane's raw pulp to extract the stalk's sweet juice. This machine harvests the cane by cutting it at the base. Rotating scrolls feed the cane to the chopper drums inside. As they chop the cane, a fan blows the lighter leaves and tops back onto the field. The heavier lengths of cane drop into the base of a conveyor, which feeds them into the transport bin that follows alongside. Trucks rapidly transport the cut cane to the sugar mill for processing. Once cut, sugarcane begins to lose its sugar content, and damage to the cane during harvesting accelerates this decay. At the mill, trucks empty their load onto a receiving table. It feeds a belt conveyor that takes the cane through 2 separate washes. The cane must be as clean as possible before extracting the juice. But first, the cane's hard structure is broken down inside this crusher, where rotating hammers break the cane into small pieces. A conveyor loads it into a milling tandem designed to extract the sweet juice from the crushed cane. In this milling tandem, the cane passes through a series of 5 or more consecutive mills. Large cylinders compress the cane fiber. The juice pours out of the milling tandem and diverts into a channel away from the bagasse, the dry pulp that remains after extracting the juice. A worker supervises the operation at each of the mills. A vat collects the juice that flows from the top and bottom of the mills. Now that the juice is extracted from the sugarcane, it's time to process it. However, before turning the juice into sugar crystals, a sample goes through a series of tests at the sugar mill's laboratory. First, a technician adds a thickener that binds to impurities in the juice and then filters it to obtain a clear, clean juice. Then, he pours it into a polarimeter, a machine that measures the concentration of sugar. The juice from the mills now falls through this 10-meter-high tower as sulfur dioxide vapors rise through it. This process, known as sulfitation, bleaches the juice. Then the juice flows through a device that measures its pH level. While at a separate vat, workers add powdered lime to water, preparing a solution to which they will then add the juice. An agitator mixes the cane juice and lime solution for about 6 hours to complete a process called alkalization. It regulates the juice's pH level and helps clarify it. In reaction to the lime, the juice's color changes from brown to yellow. Next, the juice goes into these clarifier tanks. It takes over 2 hours for the juice to settle and for the impurities to fall to the bottom of the tank. A sample taken from the tank shows how the sludge collects at the bottom, while the clarified juice collects at the top. Next, we'll see how this clarified juice transforms into flowing crystals of white sugar. Christopher Columbus never made it to Asia, but discovered the Caribbean and later brought sugarcane plantings there. Sugarcane provides sugar, but also syrup, molasses, rum, and ethanol. The many types of sugar available in stores differ in crystal size or color, depending on how they're processed. Workers filter the residue, known as mud, from the clarifier tanks to extract any remaining sugar. There's no waste here. The mud will fertilize the cane fields, and the bagasse will be burned as fuel. The clarified juice collected from the clarifier tanks now boils in a series of evaporators. This brings the concentration of the sugar in the juice up from 15% to 60%. Then the juice collects in 15-ton tanks to clarify even more. Any sediment left in the juice floats to the top. A rotating paddle skims this residue off to the sides of the tank. These tanks produce a type of syrup that goes on for still more processing. Workers now pour microscopic sucrose crystals suspended in alcohol into the syrup. This milky solution binds to the sugar present in the syrup and helps draw it out. Next, it all boils in large vacuum pans, forming sugar crystals. As the water in the syrup boils away, workers regularly check to see how the sugar is crystallizing. The goal? To produce a thick crystallized paste known as masquite. It then goes into a high-speed centrifugal machine to remove the sugar crystals from the uncrystallized syrup. Inside, the sugar spins at 1200 revolutions per minute. This action draws the molasses to the outer shell of the machine, while the crystals remain in the inner basket. Sprays of water wash the crystals. Then the water is drawn out so that only the crystals remain. This centrifuge works much the same way as a washing machine set on the spin cycle. It draws out moisture from the sugar, much like you draw out the wash water from a load of laundry. Next, a conveyor belt carries the sugar crystals out of the centrifuge. This mill produces raw sugar, which has a higher molasses color and is unbleached, and plantation white sugar, which has less molasses and is bleached a brilliant white. The sugar on the conveyor now goes into a large dryer. Hot air blows into this dryer to bring the sugar's humidity level down to 0.02%. That's standard for table sugar. The dried sugar pours out of the dryer into a bag on a scale. It's full when it weighs in at 1,000 kilos. A hoist then carries the bags to a platform at the far end of the packing facility. At 3,000 kilos, that's a heavy load. It lowers each bag over a chute that leads to the factory's main floor. Workers carefully open each bag in turn and pour out the sugar directly into the chute. It feeds an automated packaging machine, which fills a series of 2-kilo plastic bags, seals them, and separates them. This packing facility produces 200,000 bags a day. That means processing 400 tons of white sugar daily. This fine plantation white sugar is available in a variety of convenient packaging options, and that should sweeten anyone's day.